we're studying a new unit on what are called conic sections. Conic sections are cross sections of cones, and the four conic sections we're going to cover are circles, parabolas, ellipses, and hyperbolas. And today we're going to cover circles. First, just let me talk about where the conic sections come from, and then a little bit of applications that I'll leave a lot of that to the sections where we do each one of these. So I've drawn a cone over here, and another cone on top of it. And basically I'm going to cut through it and create cross sections. We've did some of this in geometry just in the last week or two. If you cut across the cone at parallel to the base, you will get a circle. If you cut at an angle but don't go through the bottom, you get an elongated circle, which is called an ellipse. Sometimes you guys call it an oval, but the mathematical term is ellipse. Now, if you cut through the circle, through the cone, but cut through the bottom as well, you get a figure that looks like this. That is called a parabola. If you cut straight up and down and hit both cones, this, do another one up here, just basically create a big cut all the way through both of them, you get what looks like two parabolas, but they're not actually. They're called hyperbolas, and they're a different equation. Okay, so in this section, we're going to do these not actually just geometrically, but actually with algebraic equations, which is the much more useful way of learning them. It's what's used actually for these in general. Let me talk a little bit about the applications of them, and then I'll leave the later ones to a large degree for when we do them, which will be in the next lessons. So let's start with a circle. A circle is actually fairly uncommon in nature, but humans create them. Orbits of satellites, GPS satellites, are in circles. Also, we make things out of circles, which we need the equation for in order to manufacture them. Things like wheels and clocks, anything you can think of that is circular. There's an equation behind it to generate and manufacture it. Parabolas are quite common in nature. Objects that move through a gravitational field move in a parabola. So if you throw a basketball towards a hoop, the shape that it actually goes through the air is a parabola. Also, lenses in your eyes, for example, your glasses, satellite dishes are all parabolas. Ellipses, planetary orbits, are all in ellipses. Hyperbolas, a couple applications for that. One is when you have radio interference waves with each other, they form hyperbolas. Also, planetary objects like asteroids or comets, if they come into the Earth's solar system and exit, they go in the shape of a hyperbola as well. So that's just some of the applications of it. Today we're just going to focus largely on the circle. So the circle, I'm going to write an equation first of the circle. Use x squared plus y squared equals r squared, where x and y are points on the coordinate plane, and r is the radius. This is an equation of a circle that goes through the origin. I'll give you the more general one in a moment. Through the origin, or 0, 0. I'm going to first, before we go into this, actually graph this on a graph board. You can try to do this in your notes as well. Just put points in and graph it to show you how it works. Notice this also, by the way, looks like something you probably have seen before. A squared plus b squared is c squared, or the Pythagorean theorem. It is in fact the Pythagorean theorem, and I'll show you that as I graph this. Okay, so I'm going to start with the equation x squared plus y squared equals 5 squared, or 25. Just so I can graph a real equation. This means the radius is 5. Typically you don't see it as 5 squared, but rather as 25. I'm going to create a little chart where I graph it, so I'm going to put some x's in and get some y's. I'm going to start with an x of 5. I'm going to erase this up here to give myself some room to do some calculations. Okay, so if I put in 5 into this equation, x is 5, I get 5 squared plus y squared equals 25. Or 25 plus y squared equals 25. Or subtracting 25 from both sides, y squared is 0. Or y is plus or minus 0. If you take the square root, or just 0. So you get 5 0. There's my first point. If I'm at negative 5n, I get the exact same set of equations because negative 5 squared is still 25. So I get y is 0 as well. Let me plot that one. Okay, now I'm going to put in 0 for x. If I put 0 in for x, I get 0 squared plus y squared equals 25, or y squared equals 25. Take the square root of both sides, and I don't just get 5, I get plus or minus 5 when you take a square root. So I get 0, 5 and minus 5. So that means 0, 5 up here, and 0, minus 5. And you can see it's starting to take the shape of the circle already. I'm going to take a couple intermediate points. I'm going to put in 4. If I put in 4, I get 4 squared plus y squared equals 25. 16 plus y squared equals 25. Subtract 16 from both sides, and I get 9, and y is not again 3, but plus or minus 3. And let me graph those points. 4, 3, 4, negative 3. Put negative 4 in, I'll get the same thing, because negative 4 squared is also 16. And I get negative 4, 3, and negative 4, negative 3. Again, I could put in 3. If I put in 3, I'll get, let me just graph that, put that in. 3, I get x, or 3 squared, which is 9, plus y squared equals 25, or y squared equals 16, or y equals plus or minus 4. So I put 3 in, I get 4, and that works for negative 4 as well. And so I get 3 here, and negative 4. There we go. That's probably enough points to graph it. I picked numbers that gave me nice whole numbers, but you could easily pick in, for example, 1 here. If you put 1 in, you're going to get that y is radical 24, which is pretty close to 5, somewhere between 4.5 and 5, and you'll get some point like that. So it gives you all these points in a nice circle. Okay, and there's my origin, 0, 0. Now I'm going to show you why this is the Pythagorean theorem. If I take this point here, for example, or any point on here, I can create a right triangle. The coordinate plane creates a right triangle. This is x, which in this case, as I drew it, is 3. This is y, which in the case I drew it is 4, but I'm just going to leave it as x and y, because I could create this triangle anywhere. And this is, as you can see from the picture, the radius. So by the Pythagorean theorem, x squared plus y squared must equal r squared. Okay, so that's the equation of a circle, not just the geometric drawing of one. Now we're going to try the more general formula, because it doesn't always have to be around the origin. So the more general equation for a circle, this is 0, 0, is x minus h squared plus y minus k squared equals r squared. Okay, r squared, r is still the radius, and h and k is the center of the circle. And r is the radius. So let me give you an example of that, and then we will plot one. I'm going to do a x plus 2 squared plus y minus 1 squared equals 9. There's my equation. Raise this up here. Put a little higher. Just have a little room. Okay, so what this means is that the center of the circle is negative 2, positive 1. Look at the equation, it's x minus h. So this has to be written, it could be written as x minus minus 2, although it's typically not. So that means the center is negative 2 here, and the center here is 1. So, and the radius is 3. So my center is negative 2, 1, and my radius is 3. Okay, like the other one, I'm going to demonstrate some points on this. I'll create another table over here and pick some easy to calculate numbers. First of all, I'm going to put the center on here, which I know is negative 2, 1. I'm telling you that. You don't actually really know that yet. And I'm going to write my equation up here, the more general one, and then I'm going to do some actual calculations with it to show you that again. That should have been r squared. That this works. I mean, obviously, as we'll do in a moment, I'm not going to recalculate this, but just a couple I want to show you, and then we'll just actually draw it without just looking at the equation. Okay, so I'm going to pick some points out. I'm going to start with the easiest points to give, which let's start with x is -2. If I put -2 in here, into my equation, I get -2 plus 2, which is 0 squared, plus y minus 1 squared equals 9. Well, in other words, y minus 1 squared is 9. Take the square root. Don't distribute this. Just take the square root. You get y minus 1 equals square root of 9, which is not 3. It is plus or minus 3. That gives me two equations. Y minus 1 equals 3, and y minus 1 equals -3. This one gives me a y of 4, and the other one gives me a y of -2. So there's my 2 points. -2, 4, and -2, -2. And you can see already it's starting to take shape. So I've got my center there, and these were each 3 apart, my radius. Okay, now let's do another point. Again, I'm going to pick easy to do calculations. I'm going to pick an x of 1. So I'm going to erase this again. If I put 1 in here, I get 1 plus 2, or 3 squared, or 9, plus y minus 1 squared equals 9. Subtract 9 from both sides. I get y minus 1 squared equals 0. Take the radical of that, square root of that, you get y is 1. Or sorry, y minus 1 is 0. Sorry, minus 1 equals 0. Plus or minus 0, but that's just 0. Or y equals 1. So my point is 1, 1. And then I can put in, let's say, 1, 2, 3, that's over there, -5. -5, I get exactly the same calculation because this becomes 9. And that gives me that value there. Now, I could do the intermediate ones. They're a little painful. I'll leave that for an exercise on the homework. But you can just connect these now. And there we go. The center was -2, 1, which I didn't know other than I told you, but you can kind of see the center is -2, 1 now. And the radius is 3. And again, the Pythagorean theorem, I can take any point here, do that, x, y, and r, and I would get, so that's not x, that's, in this case, 2, 3, sorry. Actually, what this is x plus 2 and y minus 1, and this is 3. So you get x plus 2 squared plus y minus 1 squared equals 3. Okay, so that gives you shows you the equation actually works. For the rest of this time, though, we're just going to assume it's correct now, as I demonstrated it was, and just graph some more generally. So, for example, if I have an equation, x plus 4 squared plus y minus 2 squared equals 4, I can take the center out of this just from the equation. The center is -4, +2, and the radius is 2. And I can graph it from that without plugging any points at all in. I can just graph the center, which is -4, +2, and then I take the radius and I count out from each side, from the center, 2 up, 2 down, 2 right, 2 left, and I graph like that. And there's my circle, just from this equation. I can plug in points just to demonstrate it works. If I put in x is, let's say, -2 here, for example, I should get y is 2. Put -2 in here, I get -2 plus 4 is 2 squared, or 4 plus y minus 2 squared equals 4, or y minus 2 squared is 0, which gives me y is 2, that point right there. But you don't need to do that, you can just take it from the equation. Okay, I'm going to have you do a couple now. Let's check this one out. Let's do x plus 4 squared plus y plus 1 squared equals 9. Okay, pause the video there and try to graph that yourself and come back. Okay, this means the center is -4, -1, which is right there. I'll call that the center, call it O. And the radius is 3. So I'm just taking the 3, I'm going to count out 3, 3, 3, 3, and I draw my circle. There we go. That's what you should have. Okay, we'll try one more. X minus 3 squared plus y plus 2 squared equals 10. Okay, pause that. Try that one. Okay, if you're back, center is 3, negative 2. So I'll graph that, 3, negative 2. And r is not a whole number. It's in fact radical 10. Because that's r squared. So radical 10. Make sure I got the right number. I think it is 3.16 if I remember. Yeah, 3.16. So that means I have to count out 3.16 in all directions. 1, 2, 3 and a bit. 1, 2, 3 and a bit. 1, 2, 3 and a bit. And 1, 2, 3 and a bit. And then draw the circle. Oops, that's a little potato-like. There we go. So it doesn't have to be a whole number over here. And by the way, the center doesn't have to be either. Okay, that's how you graph a circle from an equation, where the equation comes from. Now I'm going to do the reverse. I'm going to graph a circle and have you write the equation. So let me give you an example. And then I'll have you do a few. Okay, not too potato-like. Okay, so there's my circle. So what you need to do is look at it and say, what is the center first? Which is 1, 2, 3, 1, 2, 3, 4. 3 and 4. Now, I wouldn't even necessarily have to put that dot in the middle, and you still should be able to tell where the center is, just by kind of taking a line and drawing it across like this, and doing the same thing here. You can see it'll meet at the center. Okay, so the center is 3, 4. The radius will be from the center. You need to know where that is, and count out to a side of the circle, 1, 2, or 1, 2. So the radius is 2. Therefore, the equation is x minus 3 squared plus y minus 4 squared, not equals 2, but equals 2 squared, or 4. Okay, let me give you another one. Draw one. Let's do it here. Here, actually. And you may not be able to count these very well, so I'll give you the center in a moment. And that is very potato-like. Okay, there's my circle. This point, by the way, is going to the left 5 and up 4. Okay, pause the video there, write down the equation. Okay, if you're back, the center of this is negative 5, positive 4, and the radius is 3, just counting out 1, 2, 3. Okay, that gives me an equation, which is x minus 5, which is plus 5, and y minus 4 squared equals 3 squared, or 9. Remember to square the r, that's the most common error in these. Okay, that's it for getting a graph and writing an equation. The thing you have to be careful of in both cases, both we're graphing them and doing the reverse, is make sure you reverse these two signs. It's x minus h, y minus k, not x plus h, y plus k. So this center is negative 5, positive 4. Okay, one last idea in circles. We are now going to give a problem where I give you the center, and I give you a point on the circle, not the radius. And you're going to give me the equation and be able to graph it. So let's start with a center at 1, 5, and it goes through the point 2, 3. Okay, so I'm going to graph it. Center is 1, 5. Point on the circle is 2, 3. Okay, so this is, by the way, the radius you can tell, I mean, from here is from here to here. I just don't know what it is right now. The way you solve this is by using the Pythagorean theorem. Remember, that is where the circle comes from. 4, the radius. Okay, so think of this as the radius here. You can use, just like in the distance formula, you can create a little triangle there. And this is 2, that's 1. And the radius is 2 squared plus 1 squared, or radical 5. It's easier to do it graphically again. You can use it by the distance formula by using those 2 points and finding their length, but it's definitely easier to do it graphically. So I know the radius is radical 5 from this little tiny picture there, which hopefully you can see. I know it's going to be kind of tiny in the camera. Okay, so let me regraph that without that mess in the middle there. 1, 5. So the radius is radical 5, which means the equation is x minus 1 squared plus y minus 3 squared. Sorry, not 3, 5. My circle of center is 1, 5. And that equals radical 5 squared, which is just 5. And radical 5, just so I can graph it a little easier, is 2.23. Okay, so I can graph it just by doing 1, 5, and then counting out 2.23, 2.23, 2.23, and 2.23. And I know it goes through that point because I just used that to calculate it. And there we go. There's my circle. Okay, I'm going to have you try one now. I already saw this here. I'm going to give you a new point, new center and a new circle, or a new point on the circle. So the center is going to be 6, negative 3, and the point on the circle is going to be negative 2, positive 4. And I'm going to erase this. Okay, so find the equation. Pause here. All right, if you're back, I'm going to graph it first. 6, negative 3 is right there. And that's my center. Call that O for center, the origin of the circle. The point on the circle is negative 2, positive 4. It's a big circle. And there is my radius. I'm going to drop down here, create my right triangle. I'm going to have a hard time drawing the circle, by the way, because I've run out of room, but that's okay. I'll just get the equation. This distance here is 6, and then another 2, so that's 8. And this distance here is 2, 4, 6, 7, it looks like. It's 4 minus 3 or 7. So the radius is square root, a radical of 8 squared plus 7 squared. You can leave it as a radical if you want, or you can just write it as a decimal. So radical 113. Actually leave it as radical 113, and I'll write it as a decimal as well. Second radical 113 is 10.63, and that gives me my radius. Okay, so the equation of the circle is x minus 6 squared plus y plus 3 squared equals radical 113 squared, or 113, which is why you want to leave it like this, because you're going to square it in the equation. In terms of what this looks like, it's 10.63. It's a huge, it's like right up here. It's a huge circle. Okay. Let me erase this. And I'm going to summarize, and then you can work on the homework. Okay, so the circle equation, here's the summary, is x minus h squared plus y minus k squared equals r squared, where h and k is the center, and r is the radius. This comes from the Pythagorean theorem. And from this, you should be able to graph a circle. If I give you the equation, or give the equation, if I give you the graph, or if I give you the graph, or if I give you a point on the circle. Okay, that's it. Summary for circles. By the way, for college algebra, you're going to have to know how to complete the square. I'll do that in another video. Okay, homework for, this is homework 26 for geometry and AGEO. It's a worksheet, and there'll be 2 of them actually, worksheets, 2 of them. I'll have them do on separate days. And do not do the book problems. Some of you I found out do not have books. And then for college algebra, You can only start the homework because the homework is both parabolas and circles. But do homework 29, first half. And also remember that you need the completing square, which I will create in another video. All right, that's it. Thanks for your time.